Okay, so welcome to the channel. This is my first video as a creator. This is also the first video of this channel, so please overlook any faults that you might find in this video. So what we are trying to do today is solve this particular problem, that is the Leetcode problem of the day. It's number 652, find duplicate subtrees. It's a medium level problem and it says, given the root of a binary tree, return all duplicate subtrees. For each kind of duplicate subtree, you'll only need to return the root node of any one of them. Two trees are duplicate if they have the same structure with the same node values, right? So let's take this as an example. The first example that we are given by Leetcode, right? So what do we have here? First, we have the very obvious and highlighted duplicate subtree 2 4 2 4, right? But we also have this particular subtree that you might tend to overlook 4 4 and 4. You might argue that 4 is a single node, but if you consider its left and right subnodes, left and right nodes, considering them as nodes with null value, you might see that every leaf node is also a subtree, right? So how do we represent how do we solve this particular problem? We simply have to take the representation of any particular subtree, and then we'll also have to record the number of occurrences of this particular subtree, right? Very simply, let's take this particular subtree, right? And you'll see that there are two occurrences, correct? So the representation, that is very evidently subtree and the number of occurrences. How can we represent this? We can have a map structure to store the representation of the node and its number of occurrences as a key and value pair, right? So what is this 4xx, 2 4 triple x, 1 2 3 4x, 2 4 4, this particular notation? What is this? This is very simply the representation of any particular node. You see, for 4xx we are considering this particular node, right? The root value is 4, the left value is x, that is empty, null. The right value is x, empty, null, right? So this as a subtree can be represented as 4xx, and the number of occurrences of this particular subtree is 1 2 3, right? So the number of occurrences is 3. Similarly, 2 4 x x x, it's 2 4 x x and x, right? And this particular occurrence is repeated twice, so 2. And this is the representation of the whole tree that we are given in this example, right? So what's the first thing that we are doing over here? We are replacing every null node with x, right? So in C++, we are solving this in C++, right? So how do we code out that if a root is null, if the value of a node is null, just replace it by x in our notation. We can simply write if not root, return x. You can change it with your value of choice, right? Just keep it a string, and what we are doing is, if the value of root is null, then we are triggering that return x. Why return x? We'll get to that in a second, but we are returning x to store in our representation, right? The subtree representation. The next thing what we will do, we will now traverse our particular tree to find out any duplicate subtrees. To traverse, there are many alternatives to traverse a tree. We have BFS, DFS, but we'll not get into that for this particular problem. We have post order, pre-order, and in order traversals, right? For this particular problem, what we are doing, we are first traversing the left subtree, next we are traversing the right subtree, next we are going for the node, root node. Which traversal does this remind you of? Left, right, node. It's very evidently the post order traversal, right? So we will take the post order traversal. We are using this particular function solve to solve for the duplicate subtrees. So first we will call the same function recursively on the left subtree. Next we will call the same function recursively on the right subtree, and at last we will take the value of the root node for each subtree, right? The root node of a subtree. Now why we are using toString? Because we are storing this whole value in a string variable. So now you understand why x must be a string, because we are returning the value of this particular function and that will be stored in a string variable. So this needs to be a string, and after this we'll also return the str, right? So if the root node is not null, so we will not be returning x, we will be returning the str, that is the root value, right? Now once we are done, we have the representation of a particular node. So now we will store this representation in our map that we have already created right over here, along with the number of occurrences. So we can simply do that in this particular statement, map str plus plus. So in MP map variable, if the str particular string, if let's say 4xx is already recorded in our map, so we can simply update its number of occurrences, right? If it was 1, plus plus will increment it by 1 and make it 2. If it was 2, it will increment it to 3 and so on, right? But if 4xx is not already present in our map variable, this particular statement plus plus will simply create a new entry of 4xx and updates its number of occurrences to 1. Okay, so creating a new entry and updating existing entries can be done with this single statement. If you know maps, this particular problem will be very easy for you. So once we are done updating the entry in our map, we can compare if it's greater than 1 or if it's equal to 2, and if it is equal to 2 or greater than 1, we can simply push back that particular root in our result variable. What's our result variable? It's simply a vector that we have in our main function. The find duplicate subtrees function was provided by Leetcode themselves, right? Why is it vector? Because just now you have seen that there can be multiple types of subtrees, 2 4 comma 4. So there can be multiple tree nodes that can be our answer. So we have to store all of those tree nodes in a vector, right? So over here we will push back each root of the duplicate subtree that we find in our result variable over here. Okay, and that's it for our function. Now coming to the main function that's provided by Leetcode, we'll simply at first create the vector that we require to store our particular answer. Next we will call the function that we just created with the root node and our particular vector as the arguments, function arguments, and then we can return the answer, right? Now I might have missed this particular thing, that why is there a comma, right? Why are there commas over here? So commas are usually present because of certain edge cases, right? Let's try and run this particular program and see if this causes any problem. You see these are accepted, but what if we remove the separators? We're using the commas as separators, right? So what if we remove the separators? See, for normal cases it will not cause any problem, right? For these cases it will not cause any problem, but let's try and submit this. There must be an edge case that will trigger that particular problem. Yes, you see we have the wrong answer over here. So the expected answer was 1 and the output was 1 22 1 1. Why is this the case? You see, let's just take an example of this 1 2 2 1 3 1 2 2, right? So over here it's very evident that 1 2 2 is occurring twice, once over here and once over here, right? But 1 2 2 is occurring twice, so we can say that 1 2 2 is a duplicate subtree. But what if I place the spaces like this? These are the 6 nodes in our tree: 12, 2, 1, 3, 1, 22, right? So 12, 2, 22, none of them are duplicate subtrees, right? So if we do not place any separator, this causes the confusion of 12 and 2 and 1 and 22 to be considered together as 122 and consider this a duplicate subtree. So to avoid this confusion, we must place the spaces properly, right? So you can either add a space over here, you can either add a simple space over here, or add a comma as a separator. Anything will do, right? Anything will do. So what we had over here is simply 2 commas as our separator. Let's try and run the program again. You see, this doesn't affect any of our previously accepted test cases, but if we try and submit this program right now, it has been accepted, right? So now you know that why we added these separators. I hope the code was easy enough, and I hope my explanation was clear enough for you to understand. And yes, this is a medium level question, but if you know tree traversals and if you know maps and how to use them, this should be pretty easy for you with a little practice. That's it for this video, and let me know if you have any suggestions on my future videos regarding the improvement of this video and anything and everything else. Any type of you know what to do. Okay, like, share the video if it's good. If you think this is good, like it. If you have any suggestions for me, you can put them down in the comment section, and I'll definitely get back to each of you. That's it for this video. Thank you.